One of the most common things we need to do in programming is keep track of state. That means what state the program is in, or what state a player character is in, or what state is the visualization in. Has the person won, right? Winning is a state. So if you want your user to be able to win at a little mini game, that's a state. How do we keep track of that? Well, that's what I'm going to talk about in this example. So here I've got a beautiful design, very carefully done for an amazing game, very carefully. It's an example game. The game is Mouse Click 2000, and the object of this game is that you have to click a mouse in order to win. And if you don't click fast enough, you lose. And what I've done here is think about the 4 different kind of screens I'm going to show in my game. So when the game first starts, there's going to be a screen that says press any key to start, right? Once the user does that, they'll then get the next screen which will say click the mouse to win. And there might be a timer there counting down. And if they click fast enough, then they win the game. Yeah, they win. And so they get a congratulations screen. But if they're not fast enough, unfortunately, they lose. They lose this game. But even if they lose, or if they win, if they lose or they win, they can play again, right? So you press any key to play again, and then they can go back to the start and try it again and see if they can click it the second time round. Maybe they'll be lucky. I think it's the sort of game that people are going to want to play all day long, so you actually need this ability to restart it. All right, so enough of that silliness. Here's the starting point for my game. What I've done before I began the video was I've just got a pretty basic P5.js sketch here, and I'm setting up the canvas, setting the text size and stuff like that. And what I've done is I've made a function for each of the different screens that I want my game to have. So I've got a screen for the start, a function for the start screen, a function for the play screen, a function for the timeout, you know, like lose screen. Actually, lose might be a better name for that one. And let's say draw win instead of draw victory, just to be consistent. So I've got a function for each of those. What I need to figure out is how do I change from one to the next. So like in the draw function, I can put draw start here if I'm in the starting point. But how do I change it so that when it's time for me to click, instead of drawing start, what happens is I draw play. You know, so I get the play message. Well, I need a way to keep track of what state the game is in, and that's what I'll use to do this. Let's click back to my little sketch here, and if I take this a bit further, you know, this is just an example really, so but it is always a good idea to storyboard out your sketches, you know, so if you have an idea for a game, just start by drawing the screens that you think that game needs to have. And it's a really useful starting point, and I'll show you why. Like, firstly, what it lets us do is identify, like one thing you could do is say, okay, well, I need 4 different functions that are going to draw these 4 different parts of the screen. That helps you keep your game organized. But what we're really thinking about in this example is how do I move between these different screens, right? So like I said at the start, when it first begins, you get this welcome message, and if you press any key from here, you start playing, right? Any key. And then once you're in here, you have to click the mouse. So if you click the mouse fast enough, then you'll win. So click fast and you'll win. And if you don't click, or you know you click too slowly, you'll lose. So that happens if there's a timeout. If time runs out. And then once you've done these, like either you've won or you've lost, you're definitely going to want to play this game again. So if you click any key at that time, you go back to the welcome message. Any key. Any key. Right? So by sketching it out, I've got this little model of how my game works. It's not just the screens that I need to think about when I'm programming this game. I need to think about how do I change between them. So let's start coding this into our sketch. So the other thing that's would be really useful here is that I've given each one a name. So I've said start, play, lose, and win. So by naming something in my game, I can then start to work with it in the program. And a really convenient way to represent things like these states is as numbers, as just integers. So I'm going to call this state number 0. I'm going to give each one a number. So that's going to be number 0. This is going to be number 1. This is going to be number 2, and this is going to be number 3. 0, 1, 2, 3. Let's go back into the sketch and add that. So at the top of my sketch, I'm just going to say let state equals 0, right? So we start off in that first state, in the start state. So what I can do, if I have that variable, then I can say if state equals 0, draw play. Run that again, you'll see exactly the same thing, but now, not draw play. If state equals 0, we should draw start. That's better. And if I change that variable to something else, we should see a different part of the game drawn. So here in the draw function, then I can say else if state equals 1, draw play. Otherwise, if it's equal to 2, or otherwise, if it's equal to 3. If it's equal to 2, then we draw lose. And if it's equal to 3, then we draw the winning screen. So that's the play one. This is the lose one. And this is the win one. Okay, so we've got our 4 different states. We're drawing them to the screen. What we need now is a way of changing the state. So let's set the state to begin back at 0 and think about what does it take to go from that start state to any other one, right? Well, we figured that out before. From the starting state, if the user presses any key, then we should go into the play state. So in P5.js, if I go to the bottom here and add a keyboard handler, so I say function key pressed, right? And if any key is pressed, I can just say state equals 1. So press any key to start, and if I press any key, I'm in that play state. It's moved. All right, let's think about the next part. How do we get from here to actually winning, right? So we'll go back to the appearing and disappearing. Like from the play, if I click the mouse, I won't worry about the time at this point, but if I click the mouse, then I should win, right? So I can add a mouse handler, and anytime the user clicks, then we go into this win state. So if I switch back and go down to the bottom, and I'm going to say function mouse pressed state, and the number of the winning state was 3. Let's see if that works. Right, so I'm in the start. Oh, I just clicked on it and I went straight to win. That's a problem. Let's try it again. Okay, press a key. Yes, so can you see the problem? If I click on it before the game starts, it goes straight to the win condition. So I need to do an extra check here. So if you think about it, if I go back to my drawing again, this arrow that goes from playing the game to winning the game, it's not just that the user clicks, it's that they click from this point. Like they click in state 1. If they click in state 1, then we should go to state 3. And here as well, like if they press any key, it should only really check it if they're in state 0. So when I click the mouse, I should say if state is currently at state 1 and they click, then we go to state 3. Only in that case. So I can click the mouse now, but it's not changing. I press any key, I click the mouse and it wins. But now I've got another problem, so I press a key to start, I click the mouse to win. If I press a key again, it goes straight back to the play. So I also need to, on the key pressed, I say if the current state is the welcome screen, then begin playing. Otherwise, else if state is the win condition, which is condition 3, state 3, it should go back to the start. Okay, so press any key to start, click the mouse to win, press a key and it begins again. Click the mouse to win, so we can go around in this little circle. All right, so what about being able to lose? Losing is very important in games, actually. So let's think about the timeout. So I said that the users should win as long as they click within a certain amount of time. So let's say that that's 10 seconds. So I'll make a variable to keep track of how long they have to click. So I'm going to say let time available, or time to click. Time to click equals 10 seconds. Is that right? Yeah, oh, that's 100 seconds. 10,000 milliseconds is 1 second. So I'm going to record this in milliseconds. 1,000 milliseconds is 1 second. And what I'm also going to do is record what time they start the game. Time started. And that's just going to start off, I'll just set it to 0 by default, but we'll set it to something else in a second. Now, so what I want you to think about is whereabouts in this transition would we record where the game starts? Like, do we sort of say the game starts as soon as this welcome screen starts playing? Probably not, right? Because they might sort of sit there for a while nervously thinking about whether they should press the key to start or not, and then finally they build up the courage to. We don't want to waste that time on our valuable gameplay. It's probably the instant that they click into, that they transition into this play state. So as soon as they come from state 0 to state 1, that's when the timer starts ticking, right? So that's the time that we need to record. And because we have these, because we're starting to think in terms of these transitions from one state to another, we now have a place where we can do that recording. So let's think about it. So not in the draw function, but the transition of the state is actually when this key is pressed. So when the key is pressed and we're on that welcome screen, we're in state 1, we change, in state 0, we change to state 1, and at that moment we should record what time the game started. And that was, the variable was called time started. And we're just going to record the current milliseconds. So that's how many milliseconds the sketch has been running. So let's just, to debug this, I'm going to actually draw that time to the screen. So if I go to draw play, I'm going to write text time started at width over 2 and 50 is probably good enough. Press any key to start. That was when it started, right? So I'll click the mouse to win, I win, play again. It's a different time again. So we are getting a different time each time through. And what we really want to draw there though is what time it currently is. So let's just say let time elapsed, so the amount of time that's gone, equals, actually I'll say let time remaining equals time was millis oops, so millis will give us the current time minus time started. And I'm going to round this down to a whole number so we don't see the decimal places, and I'm going to just write that to the screen, time remaining. So press any key to start, and then we can see the timer starts timing up, counting up. So this is actually not really the time remaining, it's counting up. So a better name would be time taken, I think. Say time taken. It's worth just going back and giving your variables a more accurate name if you've got them named a little bit wrong like that, because often later on you'll get confused. Is it remaining, or is it the amount left? Or, you know, if you give it a name that actually fits with what it's doing, you're less likely to run into confusion later on. All right, so now let's think about how do we use this this time that we've now got to start over. And you can see when I come back in, the timer resets itself. So basically what I want to do is check. I can check it actually here in the draw play function, because I'm only ever in this function when I'm in the play state. So it's a convenient place for me to check whether I've run out of time. And I can say if time taken is greater than time, what was it, time to click? I should say time allowed, that would be better. Time allowed. So if the time taken is greater than the time allowed, then what do we do, right? What do we do if the time taken is greater than the time that was allowed? Well, that's actually this one here, right? If the time taken is greater than the time that was allowed, the person has lost. So we're moving from state 1 to state 2. So we're just going to change state from state 1 to state 2. We just say state equals 2. So press any key to start. I won't click the mouse. It's tense, really tense. Time is up. So we've gone to state 2. Now we need to be able to press a key to begin again. So in my key pressed, I can say else if state equals 2, state equals 0. So press any key to start, click the mouse to win. I won! Try again. Press any key to start, click the mouse to win. I won again! Okay, press any key to start. Click the mouse to win. 10 seconds seems so long. Will I win or will I lose? I lost. But I want to play again. So, okay, we've got this thing working. It's going through all of these transitions. It lets me click from one to another. If I click the mouse in the wrong one, it doesn't suddenly take me to a win condition. I've sort of thought it through. Now, just to give you some terminology to use when talking about this, what we call this is a state machine. So it's got these 4 different states in this case, and we call it a state machine because it's a model of how we move from one state to the next. And in fact, this is a special kind of state machine called a finite state machine. It just means that there's a finite number, a set number of states in the system. But this way of modeling states and thinking about how we move from one state to another is really a really useful way of conceptualizing how things like games and other interactive sketches like that work. So definitely something you can use in your own sketches. Just one last thing I'll show you. It is a little bit funny that we just use numbers to represent the different states, and there is a slightly better way to do this in JavaScript. I mean, there are a number of different ways to do it, but one thing we can do is say const instead of let. And const is another keyword in JavaScript, and it lets you define a constant. So I can say const start equals 0. So it's still a kind of storing a value into the constant. It's a bit like a variable, but the value of the constant can never change. So this can be sort of useful for things like labels in your code. So here I've got start play equals 1. Lose equals 2, and win equals 3. And it's convention, it's a convention to write constants in capital letters. You don't have to, you can write them however you like, but I like doing that just so I can see in my code, it just reminds me that it's a constant. But the advantage of doing this is once I set these constants up, anywhere where I was using a number, I can instead use the name of the constant. So if state equals start, then if state equals play, if state equals lose, and state equals win, you can see that becomes more readable. And then also later on here I switch to a different state, right? So state equals lose. The meaning of the code is a little bit more obvious for someone coming along and reading it. And here again, if state equals start, then it goes to play. And if it equals win, then it goes to start. And if it equals lose, then it goes to start. And finally, with the mouse pressed, if the state is play and they click the mouse before it times out, then it goes to win. And that should all work exactly the same. I can still win, and I can still, if I let it time out, it'll time out. So that is a simple state machine, definitely something you can use in your creative coding, and I would be really interested to see how you use that before time is up for the assignment. Happy creative coding.